Triangle A has side lengths 4 and 7 with a non-contained angle of 50 degrees. Determine the unknown side lengths and angles. Round to the nearest 2 decimals if necessary. We will begin by drawing out our triangle. If you want to recap on how to draw angles so you can draw this 50-degree angle shown on the screen, please refer to one of our previous lessons. We also have our known side lengths of 7 and 4, and so we will call our unknown C and our 2 unknown angles big B and big C. Now the first thing we want to do is bring out our sine law formula and fill in the numbers that we have already been given. So now we have sine of 50 degrees over 7 is equal to sine of B over 4 is equal to sine of C over little c. We will first start by solving for the angle B using this left sidemost part of the formula. We will start by cross-multiplying 4 to the other side to get 4 sine 50 degrees over 7 is equal to sine B, and then we will take the inverse to solve for B. If you want to refresh your memory considering inverses, please refer to our lesson on inverses in trigonometry. And now we have that 25.96 degrees is equal approximately to the angle B. And please store this exact amount in your calculator because you will need it later. Now that we have two angles, we can solve for angle big C. And we do this by subtracting the angles that we have from 180 degrees, and this will give us 104.04 degrees to BC, approximately. And please also store this exact amount in your calculator to be used for later. The only thing we have to do now is solve for little c, and we will do this by equating sine 50 degrees over 7 to sine of 104.04 degrees over little c. We will first divide both sides by sine of 104.04 degrees, and this will give us this following equality. And the only thing that we have to do now to solve for c is to take the reciprocals of both sides. You could also rearrange this equation to get c onto the other side, or you can raise both to the exponent of -1. But in either case, we get 7 sine 104.04 degrees over sine 50 degrees is equal to c. And now we just evaluate this exact amount to get c to be approximately 8.86 if we round it to 2 decimals places. Now that we have all of our angles and all of our sides, we have solved the triangle. Once again, if you want to refresh your memory on a few concepts such as inverses or angles, please refer to our earlier lessons in trigonometry. Now we will move on to our second question. Triangle B has a side length of 12 and angles 100 degrees and 40 degrees. Determine the unknown side lengths and angles. Round to the nearest 2 decimals if necessary. Once again, we have our drawn triangle right here, and this time we have been given 2 angles, and so we can solve for big C pretty easily, and we do this by simply subtracting both numbers from 180 degrees to give us 40 degrees. The next thing we are going to do is take our sine law formula and plug in the numbers that we have. So we have sine of 40 degrees over A is equal to sine of 100 degrees over B, which is equal to sine of 40 degrees over 12. You may notice that we have 2 very similar numbers here, and we can deduce that this is an isosceles triangle and that A is equal to 12 since we have these fractions to be equal, and there is no other value that A can be. Now all we have to do is solve for the side B. We will take sine of 100 degrees over B equals to sine 40 degrees over 12 in order to solve for B. The first thing we are going to do is cross multiply B to the other side. So we have sine of 100 degrees is equal to B sine of 40 degrees over 12. And then we are just going to multiply both sides by 12 and divide both sides by sine of 40 degrees, or simply just divide the circled fraction into the other side, and we have 12 sine of 100 degrees over sine 40 degrees is equal to B. Evaluating this with your calculator gives that B is approximately 18.39.